This is going to be my solution for day 2 of the 2022 Advent of Code puzzle. And we're going to do rock, paper, scissors today. And apparently what's happening is you're setting up tents on a beach, and to decide who gets closest to the snack storage, there's this rock, paper, scissors tournament. So for rock, paper, scissors, you've got 2 players, and for each round, each player simultaneously chooses a hand shape that represents a rock, a paper, or scissors, and then the winner for that round is selected using the rules. The rock defeats the scissors, scissors defeats paper, and paper defeats rock. And of course, if they both choose the same shape, the round ends in a draw. Now, you're given this encrypted strategy guide, and it's going to look like this. This is the input. And so there are 2 columns. One column has A, B, or C, and the other column has X, Y, or Z. And the elf starts to explain that A represents rock, B represents paper, and C represents scissors, but doesn't tell you what the second column is. So we're going to assume that the second column is X is rock, Y is paper, and Z is scissors. So what'll happen is, this first one here, A and X, would end in a draw because A and X both represent rock. So the left column is the elf's move or the opponent's move, and the right column is your move. Okay, let's see how we can represent this. It's actually pretty easy. I'm actually going to use Replit. I'm going to alternate between Replit and GitHub Codespaces, and I can simply use 2 lists to represent the moves. So we'll say the elf moves are equal to A, B, and C, while your moves are equal to X, Y, and Z. And I'll go ahead and put a comment up here to remind us that the order of the moves is rock, paper, scissors. I'll need to open up that file with the input for reading and store the file handle in F, and then get the lines. Then there's going to be a total score based on the moves, and we're trying to figure out what that score is. So if I say total, it's going to start off with 0, and then for item in lines, we're going to do something, and then we're going to print the total. So we've got to figure out how to score each round. And so for that, we have to determine first whether each round results in a win, a loss, or a draw. And I've created some slides to help illustrate this. We do this in a matrix, and we put the elf's moves on the columns and your moves on the rows. And also notice that each one has a value of 0, 1, or 2, which corresponds to its index in the lists. And then we can determine if this is a win, loss, or draw by subtracting your move from the elf's move. And that'll look something like this. And at first you might be thinking, well, this is pretty easy to use a dictionary or something to set up a mapping between the moves and the outcomes, because there's only 9. And yes, that's possible. And some of the solutions that I've looked at use that. But it actually turns out that you don't have to set up 9 different conditions. Take a look at this. Down the diagonal, the yellow squares represent a draw because you're subtracting the same value from itself. So those are all zeros. So in other words, you only have to set up 1 condition to look for a draw. On the other hand, look at the green squares. those are wins. So if the elf picks scissors and you pick rock, rock crushes scissors, so that's a win for you, and the value is 2. Otherwise, the other two winning values are -1. So you don't have to have 3 conditions set up to check out a win. You only have to have 2. Everything else is a loss. So your conditions that you have to set up, there's only 3, and then everything else is going to be a loss. So let's see how that looks in code. I'm going to create a new function called round score. And that's going to take the elf's move and your move. Now I'll simply take the difference of the position of the elf's move and the position or the index of your move. Then there's going to be, again, a score associated with each of these. And that's going to be here back in the instructions. So the score is going to be the shape that you selected, 1 for rock, 2 for paper, 3 for scissors, which is just the index of each move plus 1. And then the score for the outcome of the round, 0 for a loss, 3 for a draw, and 6 for a win. So if the difference is equal to -1 or the difference is equal to 2, that score is going to be equal to 6. And I need to initialize that variable up here. If the difference is 0, it's going to be a draw, in which the score will be 3. And otherwise, you just leave it at 0 for a loss. Then you need to return the score plus the index of your move, which will be 0, 1, or 2, and add 1. That means that all we have to do now is extract the elf's move and your move from the current line. That can be done with this code because the line is going to be two uppercase characters separated by a space. So strip off the new line, split on a space, then add to the total the return value of round score with the elf's move and your move. Okay, let's run this. 12,794. And if you look down here, the answer is 12,794. Now it turns out the strategy that we assumed was incorrect, because the elf comes back and says, hey, the second column is actually how the round needs to end. So X means you should pick a move that loses. Y means you should pick a move that's ending in a draw, and Z means that you should pick a move that's a winning move. All right. Scoring the round or scoring is still the same, so a majority of this work, so actually all of this work that we've done up here is still going to be okay. But need to write a new function and call it def pick your move. And that's going to take the elf's move, and it's also going to take what the outcome needs to be. So let's start off if the outcome is equal to X, which would mean we need to pick a winning move. Now if we look up here at the order of the moves, actually I take it back. X is a losing move. We need to pick the losing move here. The losing move. So let's take a look here. What if the elf picks paper? If the elf picks paper, what should we pick to lose? We should pick rock. because paper covers rock. If the elf picks scissors, then we should pick paper because scissors cuts paper. In other words, you should always pick the move that precedes the elf's move in order to lose. Now, in the case that the elf picks rock, there is no preceding move, so we're going to wrap around and pick the end move, which would be scissors. All right, let's represent that. So first of all, let's say what happens if the elf picks the move at the end, which would be, rock. So elf moves dot index of the elf's move is equal to 0. We're simply going to return the wraparound last, which would be your moves -1. Otherwise, you're going to return the preceding move, which would be return your moves, elf moves, index of the elf's move, -1. All right, what if the outcome is for a win? Looking back up here, we just reverse the process, and you pick the following move. So if the elf picks rock and you need to win, you're going to pick paper. If the elf picks paper and you need to win, you're going to pick scissors. If the elf picks scissors and you need to win, you're going to wrap around and pick the first element. If the elf moves, index of the elf's move is equal to the length of elf moves -1, then we're going to return your moves .0, select the first move. Otherwise, we'll return your moves, take the index of the elf moves, and pick the next one. Otherwise, and this is going to be a draw, return the move with the same index, and thus the same value. Now we can actually do this the same way to compute this score, same code. All we have to do is rename this to outcome, because the second value is now the outcome instead of our move. And over here, pick your move, elf, and outcome. All right, run this and get a value of 14,979. And if we look down here, that indeed is the value that we were looking for. That is the correct. So those are my solutions for the for day 2, and I'll leave a link to the REPL in the comments below.